Hello and welcome to second part of the lecture on the topic types of feeds in aquaculture. This is for the course aquaculture. So earlier we have talked about different kind of feeds, different types of feeds which are being used for different life stages of the aquatic organisms, and now we talked about in the end of the previous lecture. I talked about the dry feeds. So now continue from there with the heading manufacture of dry feeds. Feed formulation and ingredient selection will usually be made to meet the known nutritional needs of the target fish species. But the choice of equipment and processing conditions used in manufacture can have major influence on physical characteristics of finished feed. We all know that while doing feed formulation and ingredient selection, we are having only one objective in mind, that how to meet the nutritional requirement or nutrient requirement of the candidate fish species or the other aquatic species. So by appropriately selecting the feed ingredient, having balanced feed formulation, we have ensured that. But while preparing the diet, while mixing different ingredients and processing it for making the pellet or the type of whatever type of feed you desire to produce, then the manufacturing process, the process can have significant impact. The process as well as the equipment being used can have significant impact on what is being produced. So in different forms you can produce the same thing. Three processing techniques that we can also see that in case of many of the food items or dishes that we consume, same thing can be produced using different equipments differently. If we add certain processes or if we use certain other kind of equipment, then we get different product. For example, these days you may get momos, very popular momos. You get steamed momos. The process is different. Momos that are fried or tandoori. So whatever type of processing or use of equipment is there, accordingly you get different kind of products or the finished diet. So here also you will have to take care that what kind of equipment, what is the process that will produce different kind of products in terms of feed. Three processing techniques currently dominate the production of dry, pelleted fish feeds, and their use usually results in improved bioavailability of the nutrients in the raw material. The processing technique, the way you are preparing the food, that of course decides whether the nutrient availability will be at the desired level or not. And that is the most important thing. These three processing techniques of grinding, steam conditioning, and extrusion invariably affect the physical and chemical characteristics of feed. Grinding, so some you may grind it to powder form, you may keep it little coarse, or steam conditioning or extrusion, depending on the steps involved in these, your food may be having very different characteristics. These characteristics include, what are the characteristics which we are going to take care? Water stability, that is going to influence water stability and durability. Pellet hardness, nutrient bioavailability, and organoleptic properties. All these characteristics are very important with regard to utilization of the feed being offered by the aquatic organism or the fish. So that may be very clear that if we are not following appropriate protocols, then we may have very different kind of feed produced. The technology used for the manufacture of dry feeds for fish is based on that developed for manufacturing feeds for terrestrial animals that we all know. Of course, you are preparing artificial diet, so for whom you are preparing, that is not a matter of concern. How we are preparing, what kind of ingredient we are using, that is a matter of concern. And usually the ingredients, many of the ingredients are similar, and the process of pellet formation is similar, so we can use the same technology. The basic steps in feed manufacture are grinding and mixing of ingredients, grinding, then mixing of ingredients, then pelleting. Maybe you can use pellet mill, expander, or extruder. So depending on what kind of equipments do you have, depending on what kind of objective, what is your objective, cutting, drying, then top dressing or coating, then cool these finally produced pellets, and then package them and store them properly, and then they are transported to the end users or farms where they can be utilized. In all these steps, if you are using a different protocol while grinding or while mixing, pelleting, whatever pellet mill you are using, expander, extruder, then in every step, even top dressing is very important, then your composition of the final product may vary. So that should be standardized first, and that should be having certain SOPs so that you get the pellet of similar composition again and again for a particular life stage of the fish. So this is a representation of properties of feed ingredients and processing conditions that may influence the characteristics of the finished feed. So the properties of feed ingredients and processing conditions that may influence the characteristics of the finished feed. What are properties of feed ingredients that may influence? Physical properties, particle size, size distribution, density, surface area. Then we have chemical characteristics, properties like moisture, lipid, fiber, protein, ash, which is for the minerals. So all this information we are already having at hand before going to take up the ingredient for producing pelleted diet or dry diet. Then functional properties like protein solubility, they are very important. Starch gelatinization, viscosity, and binding properties. Sometimes we use certain ingredients which do not have binding properties. So ultimately you will have to use binders from outside having no nutrients. So depending on your requirement, depending on the choice of ingredient, we can use different binders, or maybe we can use ingredients which are having that binding property. So these will influence ultimately the characteristics of the finished feed. So processing conditions, what are these conditions? Like temperature, pressure, moisture, time. Of course, they have major influence that we are not going to discuss here in detail. That how, if you are preparing something, then maybe anything, if you are cooking at low flame or medium flame or high flame, you may be getting different type of characteristic of that same product. And the same thing is here. If you are pressure cooking something, then for what time and how much pressure is there, depending on these conditions, you get a different result of your dish, whatever you are preparing in your kitchen. Moisture, time, everything has impact on ultimate characteristics of the finished feed. Pellet press, die specifications, very important. Diameter to length, measurements and throughput, everything will have impact on the finished feed. Then cooling and drying procedure, pellet layer thickness, what is the thickness of the pellet layer, then air speed, time, and air moisture level. So all these characteristics should have a kind of defined range where they are to be applied for the production of finished feed. This is a representation of steps involved in manufacture of dry pelleted fish feeds. Very quickly, raw ingredients when we get, then we go for grinding. Different methods of grinding are there. Then after grinding, these ingredients, it depends on how many ingredients you have taken. they are mixed together thoroughly, and then we use milling process, hammer mills, or there are other methods also. Then we go for steam preconditioning. Extrusion, there are two options: extrusion processing, steam and pressure treatment. Compressed pellets, steam or cold pressing. In case of compressed pellets, moisture content 15 to 20%, temperature 70 to 85 degrees centigrade. In case of extrusion processing, steam and pressure treatment, we have moisture content 20 to 30% and temperature 80 to 200 degrees centigrade. Drying and cooling, screening. After following any of these steps, drying and cooling is done, and then that is followed by screening of appropriate size. Then top dressing the desired size pellets with supplements, whatever you need to have, fish oils, vitamins, antioxidants, they can be used in top dressing. Then bagging or packaging can be done and stored or marketed, whatever your objective is. Now, grinding is an initial step of fish feed manufacture. Most ingredients are subjected to particle size reduction by grinding. Particle size of dry ingredients should be below 500 micron. So, while doing grinding, take care that you are grinding them to 500 micrometers or less. Different types of grinders such as plate mills or roller mills can be used, but particle size reduction by impact using hammer mills is most common. So, plate mill grinder you can use, roller mill grinder you can use, hammer mill grinder you can use, depending on that. But hammer mill grinder is very popularly used, where the efficiency wise or the size that you desire is very suitable. Grinding improves the mixing properties of ingredients, we all know that, increases the bulk density of the feed stuff, and facilitates the penetration of steam into a feed mixture that will ultimately increase its digestibility and bioavailability of nutrients. This will influence hardness, density, and starch gelatinization, and have effects on the durability and water stability. If these steps will be there, then your nutrients will be safe for a longer period of time when you are offering the pellet to the fish in the water. So, there will be more water stability and there will be less of nutrient leaching, and the nutrients will be available to the fish or aquatic organisms in proper manner. From a nutritional point of view, grinding of feedstuffs may improve nutrient digestibility that I was talking about, that it will increase digestibility via increase in the surface area, and it facilitates the destruction of some anti-nutritional factors. That is again very important point, because many of the plant byproducts, the high protein content by plant byproducts, they are having ANFs, anti-nutritional factors, and that may limit the utilization of ingredient or feed by the fish, or you can say the bioavailability of nutrients from that ingredient to the fish. So, that is also one of the advantages. These are some photographs which have been shown, again not for I'm not advertising any of these products, but these are the type of products which are shown: plate mill grinder or roller mill grinder or hammer mill grinder. Mixing. Next step, correct mixing of ingredients is essential to ensure that each pellet is nutritionally complete. If you are not able to do thorough mixing, then how you can ensure that every part of the mixture is having all the components that you have mixed? The type of mixer used depends on production capacity requirements, the bulk density of the ingredients or mixed feed, and the amount of liquid to be added. A horizontal mixer is most commonly used in the production of fish feeds. Horizontal mixer we usually use in case of fish feed production. Several factors, including the physical properties of the ingredients, particle size, shape, density, hygroscopicity, static charge, and adhesiveness, are considered, and mixing parameters like addition sequence of the ingredients, that also matters a lot, what you are adding when. So that plays a very important role, and all these things you can understand by observing the many dishes being prepared in your kitchen. Sequence of the ingredients, mixing speed and time may influence the efficacy of the mixing. So these are very common things that we all know. This is horizontal mixer, which is shown here. Then next step is pelleting. Pelleting is the compaction of ingredients by forcing them through a die opening using a mechanical process. So we all know that the dough kind of thing that is pressed against the die, and according to the diameter in the die, the opening diameter in the die, the perforation kind of things, you get the pellet diameter. So the objective is to produce nutritionally complete feed pellets that can withstand the rigorous of transport and handling at low manufacturing cost. And those desired size pellets, they must have all the nutrients, or they must be nutritionally balanced. So because of that, the processes that we discussed earlier, they are also very important. The conditioning of the feed mixture prior to pelleting is of great importance. Conditioning involves treating the feed mixture with heat, water, and pressure to convert it into physical state that facilitates compaction. Treatment with heat and water or steam includes a wide range of physical and chemical changes in the feed ingredients, including thermal softening, denaturation of proteins. All of them are going to increase the digestibility and utilization of nutrients in the diet, and gelatinization of starch. So the binding property will also come. These physicochemical changes enhance the binding properties of the particles, leading to improved pellet quality characteristics relating to hardness and durability, because you need to produce such kind of pellet which retains its nutrient content until it is consumed by the fish. So by applying the procedure very carefully, by applying all the protocols very carefully, you can produce that kind of pellet. Reduce risk of losses due to fragmentation and abrasion. Pressurized conditioners may be used to deaerate the feed mixture. Deaeration results in decrease in energy consumption during subsequent compaction and reduction in pellet porosity. Pressurized conditioners that we have. Then feed pelletizer that is being used commonly. Types of pellets now. Pellets may be produced by steam compression, expansion, or extrusion techniques. Compressed pellets, depending on the techniques that you are using, it may be called compressed pellets, expanded pellets, or extruded pellets. Come to compressed pellets. They produce sinking pellets. They will sink down to the bottom. Steam pelleting, during which the feed ingredients are compressed together, produces a dense pellet that sinks quite rapidly. Another characteristic of compressed pellet is the relatively high proportion of dust and fines in the finished feed, which affect feed wastage. The steam pelleting process involves the use of moisture, heat, and pressure to cause agglomeration of the feed ingredients into larger homogeneous particles. The feed ingredients are finely ground prior to mixing and pelleting, and some grain starch is included in the mix to ensure good pellet binding. Pellet binding is very necessary. That will ultimately affect the water stability of the pellet also. The amount of lipid included in the pellet mix does not usually exceed 10% within the pellet. If you have to increase the lipid content, then what you can do, that can be sprayed on the feed after pelleting as a kind of top dressing, maybe 16 to 20% lipid content can be achieved through this process. During pellet manufacture, steam is added to the dry feed ingredients, increasing the moisture content of the mixture to 15 to 20% depending on your requirement, and raising the temperature usually to 70 to 85 degrees centigrade. Depending on what kind of sinking pellet you wish to manufacture, you can have these parameters varied according to your requirements. This increase in temperature causes partial gelatinization of the starch, which aids in binding, we all know, of the feed ingredients. The mixture is then passed through a pellet die and the moisture content reduced by forcing air over the warm pellets immediately after they leave the pelleting machine. That way you can produce good compressed pellets. Expanded pellets, floating pellets. Expansion techniques rely on high pressure conditioning of the feed mixture within an angular expander. The configuration of the expander is similar to that of single screw extruder consisting of thick walled mixing tube, a heavy screw and attachments for addition of steam. However, the angular expander has a conical discharge valve which can be adjusted to provide a variable annular gap. Steam is added before the feed mixture enters the expander chamber where the temperature can exceed 120 degrees centigrade. The extruder screw exerts a shearing and mixing action, and this alters the feed mix structure to such an extent that binding between feed particles is enhanced. The discharge valve and pressure, 20 to 30 bar per square centimeter, are adjusted hydraulically during operation depending on the desired conditioning. The degree of starch gelatinization obtained by expansion can exceed 60%. In comparison to compressed pellets, the pellets produced by the angular expander have improved hardness and durability, and the production capacity is higher in case of this machine. The lipid content of expanded pellets can be increased to 20 to 22% by top dressing with oil. That can be achieved in other methods also. So, this is the angular expander, the photograph of angular expander that is shown here, and expanded pellets which are available in different forms, different shapes. They will be a kind of floating pellets. Now, extruded pellets. Extrusion techniques were introduced in fish feed production in an attempt to increase the digestible energy content of the feeds via increased lipid incorporation. Extrusion has all the advantages of expansion technique. We have seen the advantage of expansion technique just in the previous slide. Further, due to the porosity of the extruded pellet, there is the possibility of increasing lipid incorporation by top dressing coating with oil. So, you can increase the lipid content. Although more expensive and technically demanding than the conventional compression process, extrusion pelleting technology is flexible and quite versatile. Extruded pellets are water stable for about 4 hours. That is very good water stability. 4 hours, usually what fishes do, fishes usually consume food, they are not very fussy feeders. They consume food in almost half an hour, whatever they have to consume. Usually, shrimps, in case of shrimps, they are lazy and they are little shy in feeding, accepting feed or consuming feed. They may require more time. Their water stability becomes a big challenge. So, if you are able to increase the water stability, they need different kind of hideouts or serving in the tray or something in order to consume the food properly. But may be stable for 24 hours or more if additional binders are included in the feed mix. So, that is something very interesting. The processing temperature in the pressurized conditioning chamber can range from 80 degree to 200 degrees centigrade, and the moisture content of the feed mix can be increased by 20 to 30%. In extrusion processing, the starch present in the feed mixture is almost completely gelatinized, and it is this that produces a firmly bound water stable pellet. So see the technology that just by complete gelatinization of the starch present in the ingredients, they have been able to increase the water stability. During extrusion, the feed ingredients are first treated with steam to bring the moisture content to 20 to 30% and the temperature to 65 to 95 degrees centigrade. The mixture is then passed to the pressurized extrusion barrel, where the temperature increases usually to 110 to 150 degrees centigrade, and the feed mix is then extruded through a die plate. When the hot mixture emerges from the extrusion barrel, some of the water vaporizes, leading to a rapid increase in volume and porosity. The pellets are then cooled and dried, and additional ingredients such as oils and antioxidants that we use as top dressing are sprayed on the absorbent surface of the pellets. By making adjustments to temperature and pressure profiles within the extruder and by altering the starch content of the feed mixture, it is possible to produce extruded pellets of different density and buoyancy characteristics. Your problem is solved here. If you are getting pellets of different density and buoyancy, and also you are getting good water stability, what else you are looking for? The nutrients must be available in the proper form. The attractability and palatability are the only characteristics that you are looking for, additional characteristics. But if you are having water stability here, maybe by manipulating the density and buoyancy, you can produce floating or slow sinking or fast sinking diets. Thus, there is the possibility to manufacture floating, slow sinking or sinking pellets with the same extrusion equipment. That is wonderful. And if this is used properly, you can get excellent quality pellets for feeding of almost all fish occupying all habitats, surface, column or bottom. These are some of the photographs of extruded floating and sinking pellets that are produced, and these are the references which have been used to prepare this slide. Thank you so much.